Let's say you're at a playground on a swing set. As you swing back and forth, you feel yourself repeating the same cycle, almost like a mathematical function. What if you wanted to find your location when you're 15 degrees from the highest point? Well, this is where approximations such as the Taylor series become useful. To illustrate this, let's use the example of cosine of 1 degree. You might say that cosine of 0 is 1, and so cosine of 1 degree must be a little less than that value. However, the Taylor polynomial would allow you to find the specific mathematical value approximated. Let's go back to the original question. We could start with a very simple approximation at y is equal to cosine of 0, which is equal to 1. While this leaves an error, the Taylor polynomial asks a unique question. What if we make this function quadratic? What about a cubic one? As we add more and more terms to the polynomial, the error between the actual function and the approximation decreases. But how do we know the coefficients of x to the third, x squared, and x respectively? This is where derivatives come in, or the process of finding the instantaneous slope at a specific point. Looking at the graph of cosine of x, we can visually see what derivatives are by drawing tangent lines at x values. If we were to do this at every x value, we would get the derivative of cosine of x, which is negative sine of x. When looking at the approximation of cosine of x, we can first start with the linear function of cosine of x is equal to c1 plus c2x. If we substitute 0 for x, we would get c1 is equal to 1. The next step is to ensure the slope of both the approximation and cosine of x are the same. If we take the derivative of both sides, we would eventually get that c2 is equal to 0. Now let's use a quadratic approximation. To find the coefficient of c3, we might find when the concavity of both sides is the same. So if we derive this equation twice and find the second derivative, c3 equals negative 1/2. Thus, the quadratic approximation of cosine of x is equal to 1 minus 1/2 x squared. If we kept this process going, we would eventually get the Taylor polynomial representation of cosine. Now, if we plug in 15 degrees or pi over 12 as x in our simple swing example approximation, we would find that our answer is 0.966. Well, now that you know just how important Taylor approximations are, you might just start spotting them everywhere.